Hello friends, welcome back to my channel. This is Pinakinsir and you are learning in this particular channel physics for competitive exam, that is NEET. Till the date we have just gone through some important concept regarding numerical solving, and in this particular lesson we are going to learn two progression, among which one is number one, that is arithmetic progression. Friends, you have just gone through this topic in previous standard, and in most of numericals we will be in touch of this progression and solution of it. There are some mathematical sequences, rather to say series sequences, or you can say progression, in which a typical mathematical relation is there between two successive terms. Such sequences are said to be progression. As I have said, one is arithmetic progression, in which the nature of this progression is in which between two successive terms there is a common difference. Thereby, general formula for this progression is A. It will look like this: A plus D, A plus 2D, A plus 3D, and so on up to nth term, that will be A plus n minus 1D. See here, between two successive terms, difference is D here between first and second. Again, between second and third it is D. Again, third and fourth it is D. Such type of progression, such type of mathematical sequence is said to be arithmetic progression. In short, it is written as AP. And the summation here, say A is first term and D is common difference between two terms, two successive terms. Sum of such n terms is given by, that is summation Sn is equal to n by 2 into bracket first term plus last term. From given sequence, our first term is A there, and the last term is A plus n minus 1D. A little simplification gives you, here it will be 2A plus n minus 1D. Thereby, it will be equal to A n, expanding bracket we get A n, 2 will be cancelled there, plus n minus 1D by 2. That is your summation. You can use this formula or this formula for summation of such n terms. Let us take an example. Suppose you are given 1 plus 2 plus 3 plus so on plus n, that is n natural numbers. See here, your first term A will be equal to 1 and common difference is again 1. Then using formula we will get Sn is equal to n by 2. Your first term is 1 and last term is n. Thereby n plus 1 divided by 2 will be the formula for summation of n natural numbers. Suppose you are given a sequence like this: 4 plus 8 plus 12 plus 16 plus so on 64. Okay, you can solve this particular sequence by a manual summation. but it will be a tedious process when terms are many much. See here, your first term is 4, common difference is given there, 8 minus 4 is nothing but 4, and here last term, that is 64. But for using this particular relation, you need to find out what is n, that is number of terms. So here you are having 64, that is last term, and for last term we are having such notation. Therefore you can write a plus n minus 1 d is equal to 64. Substituting for a n minus 1, for d you will get n minus 1 multiplied by 4 is equal to 60. Thereby n minus 1 will be equal to 15, or you can say n will be equal to 16. And now your summation will be equal to n by 2, that is 16 by 2, into bracket first term is what, 4, last term is what, 64. Thereby it is 8 multiplied by 68, or you can say it will be equal to 544. In this manner you can find out summation of particular sequence, particular progression in which difference between two successive terms is common. You will be in touch of this type of progression while solving physics numericals. One more formula you have to memorize. If you are given sum of squares of first n natural numbers, like 1 square plus 2 square plus 3 square plus 4 square, like that, then summation will be equal to n plus 1, 2n plus 1 divide by 6. You have to just memorize this formula. Sum of squares of first n natural numbers. This is all about arithmetic progression in which difference is common. One more term is there. Is nothing but geometric progression. In short, it is written as GP. There are some mathematical sequences in which ratio between two successive terms is common. That is, division of two successive terms is common. Like general formula, look like this: a, that is first term, multiplied with some constant, that is ar. Next term will be ar square, next term will be ar cube, and so on. Last term will be ar raised to n minus 1, that is your nth term. Such type of progression is said to be GP, geometrical progression. See here, if we divide first term, second term by first term, you will get r. Third term by second term, you will get r. Fourth term divided by third term, you will get r. So that here a is first term and r is common ratio between two successive terms, and sum of such n terms is given by Sn is equal to a into bracket 1 minus r raised to n divided by 1 minus r. This is the formula to get sum of n terms, and one condition is there. If your r is between 0 and 1, that is less than 1, means it is fraction which is less than 1, then see here, for large number of terms, that particular term, that is in bracket second term, will be very much small, and thereby you can neglect it. So that for infinite number of terms, with this condition only, r raised to infinite becomes almost equal to 0. Thereby you can say it is tends to 0, and we can neglect it, and thereby your summation will be a1 minus r. This is only with condition. If number of terms is large and if your common ratio is less than 1, then and only then we can use this formula. For example, let us take a sequence given by 1 plus 2 plus 4 plus 8 plus so on up to say 256. See here, almost figure is doubled there, and thereby we can write a is equal to 1 here, and common difference, common ratio is given by, see there, 2. 2 divided by 1, 4 divided by 2, 8 divided by 4 gives you 2. See here, last term is 256, and using this notation we can write there a r raised to n minus 1 to find that particular n, number of total terms. Substituting for a, you will get n minus 1 is equal to 256, because a is 1 only. Here r is 2 raised to n minus 1 gives you 256 is nothing but 2 raised to 8. Base is common there, thereby you can write powers must be same, and here we get n is equal to 9. And using this summation formula, Sn will be equal to a, that is 1 1 minus r is nothing but 2 raised to 9, 1 minus 2. See here, both are negative terms, and thereby we can interchange them. 2 raised to 9 minus 1. Same way in denominator. Here you will get 5 1 2 minus 1 divided by 1 minus 2 minus 1 is 5 1 1. That is your summation. Okay, if you are given a sequence like this, 1 plus half plus 1 by 4 plus 1 by 8 plus so on up to infinite, that is large number of terms are there. Here a is equal to 1. Common ratio is, you can see here, it is very much clear. 1 half divided by 1 is 1 half. 1 by 4 divided by 1 by 2 it gives you 1 half, and thereby see here up to infinite your r is less than 1, so that we can use that second formula. Summation will be equal to a divided by 1 minus r is nothing but a is 1 minus half. Again it will be 1 half in denominator, and your final answer is 2 there. Such type of sequences are very much used in solving numericals in physics. I think it is okay. This much discussion is this much discussion, I can say that it is enough for solving those numericals. For making strong this particular formula, I have given some exercise in PDF. You can have it from description box, and a link is provided there. Right now I will take your leave. Hope you are enjoying videos. Next session we will discuss some more algebra, that is binomial theorem. And yes, thanks for watching. Keep watching. See you again very soon.